Today's notes are on properties of logarithms. This is section 3-3 in your textbook. And let's just take care of some of these properties here. I believe you saw all of these in Algebra 2. Hopefully they'll make more sense to you now in Precalculus. First of all, log base a of x. Now, we can rewrite that as the log of x over the log of a. And this is what's called the change of base formula. Now, this is a very useful formula because our calculators can handle log base 10, what's called a common logarithm. They can handle log base e, it's what's called a natural logarithm, but they can't handle log base 2 or 3 or 0.5. Using something like this, we can have any base down here and we can translate it into logarithms with any new base. So this works for base 10, base e, whatever we want to translate it to. Okay, so that's the first formula we're going to deal with, the change of base formula. Second is the logarithm of two terms multiplied together. Well, if we want, we can write that as two separate logarithms added. Now be very, very, very careful. This is not the same as saying the logarithm of two values added together. So this is incorrect, but it's a very common mistake students make. So two completely separate logarithms added is the same as the logarithm of those quantities multiplied. Same thing, if you have the quantities multiplied, we can write that as two totally separate logarithms added. Now, same thing here, the logarithm of two quantities divided. We can say that is the same as the logarithm of u minus the logarithm of v. Again, two totally separate logarithms subtracted is the same as one logarithm with the quantities divided. Okay, last property. If you have the logarithm of any quantity to any power, we can rewrite that power in front of our logarithm. So we can say this is the same as that power, that number, times the logarithm of the quantity u. Okay, these four properties, keep these in mind. These are very important. I guarantee you we're going to see these quite a bit over the next couple weeks. So let's take a look at some examples of using these. So first one, rewrite as a common logarithm and evaluate. So this means 5 to some power equals 20. What's that power going to be? We don't know what that is. Our calculator cannot tell us what this is because our calculator cannot handle base 5. However, if we use that change of base formula, we can say this is the log of 20 divided by the log of 5. Our calculator can tell us what the log of 20 is. Divide that by, type in your calculator, log of 5. If you do that, you'll get an answer of about 1.86 or so. Impossible to do from here with a calculator, very easy to do from here. So if you know that change of base formula, this isn't so bad. Same thing down here. So we can write this as the log of 50 divided by the log of 3. And again, your calculator can tell you that this is about equal to 3.56. Now, just a note for you. This change of base formula works with common logarithms, natural logarithms, anything. So we could say this is the same as the natural log of 50 over the natural log of 3. If you don't believe me, try it out. You'll still get the same answer, 3.56. So all these formulas on the previous page work for common logarithms, natural logarithms, in fact, any base you wish. Okay, let's take a look at another example. Second example says rewrite each logarithm in terms of the natural log of 2 and the natural log of 5. Now, let's say you knew what the natural log of 2 was equal to. You knew what the natural log of 5 was equal to, but you didn't know the natural log of 10. Well, let's try to rewrite this in terms of 2's and 5's. Well, we know 10 is 2 times 5, so we can say this is the natural log of 2 times 5. Now I'm going to flip back to our properties because one of those properties says that if you know the log of two quantities multiplied, that's like two separate logs added together. Okay, so let's do that. So log of two quantities multiplied is the separate logarithms added together. And we have just rewritten the log of 10 as the sum of these two quantities. So like I said, if you know these quantities to start, we can now use them to find the value of this quantity. Same thing down here. Let's rewrite this in terms of 2's and 5's. Well, natural log of 5's already how we want it, but 32, hey, 32 is like 2 to the 5th power. Now, one of those properties tells us this is like two separate logarithms subtracted. Now, we still don't have this in the format we want, but we can rewrite it as the natural log of 5, which is perfect, minus 5 times the natural log of 2. So again, if you know the value of natural log of 2, you know the value of natural log of 5, we could plug those in here, use that to find this entire value to start. Okay, let's go to another example. Third example, expand each logarithmic expression. Now, just so you know, there's always some funny person who thinks, okay, that means I'm just going to take this and make it bigger. That's what expand means. Haha, very funny, but not quite what we're looking for here. So to expand this, it means let's rewrite this. Instead of just one logarithm of this quantity, let's rewrite it as a bunch of logarithms added or subtracted together. Okay, so we know the logarithm of two quantities multiplied, which is what we have here, is like two separate logarithms added together. We know the logarithm of two quantities divided, which is what we have here, is like two separate logarithms subtracted. So let's see if we can write this. We've got really three quantities, 5, x to the third, and y squared. These two quantities are multiplied, so that's going to be two separate logarithms added. This quantity is divided, so that's going to be another separate logarithm subtracted. And there we go. Now, I can do one more thing with these powers, so I'm going to take care of that too. This is the log of 5 plus 3 times the log of x minus 2 times the log of y. Now, knowing how to go back and forth between these different forms, this expanded form and then this single logarithm form, is very useful to us. Sometimes there are cases where what we have right here is easier to use. Sometimes there's cases where what we have here is easier to use. So you should be able to go back and forth between these. Realize that these quantities are equivalent. These mean the same exact thing. These are the same exact value. But if we can go back and forth between these, that'll make our work much easier. Okay, let's do the same thing with this second one. Now, we don't have a property for a square root of logarithms, so what we want to do first is write this square root as something to the 1/2 power. Square root is the same as 1/2 power. And doing that will allow us to, hey, let's just bring this half in front. So this is like 1/2 times the logarithm of x squared y. Now that we write it this way, we have the log of two quantities multiplied. Let's write that as two separate logarithms added together. So that's going to be 1/2 times the log of x squared plus the log of y. And then if we want to bring that 2 out in front, we can say that's 1/2 times 2 times the log of x plus the log of y. And there's your expanded form. Again, that's equivalent to what we started with, but we should be able to go back and forth between these two forms. Now this next example is really the same exact directions. However, I guarantee you there's a test question just like this on your upcoming assessment, and I also guarantee you a number of people will get this wrong. I'm sorry to say that, but it will happen. Here's why. Notice we have we have the log of three separate quantities. One up here on top of the fraction, two down here that are multiplied. So we know this is going to be written as three separate logarithms. What's up here minus the log of y squared and log of z to the fifth. However, here's the mistake people make. Well, let's run through this. So this is going to be the log of x to the fourth minus the log of y squared. And then since this is multiplied, we're going to say plus the log of z to the fifth. Now, this appears to be okay, and a number of people will put this exact answer on your next test. However, since both these quantities were on bottom of the fraction, we really need to subtract both of those quantities. Now, one thing you can do is distribute that minus sign, but that minus sign is really the key to this problem. Without that in there, and without those parentheses, I'm sorry, you just got part of this problem wrong. Now, we can still take care of those powers, but that's not really the key to this problem. The key to this is how to deal with that minus sign, and you deal with it by putting parentheses around whatever's on bottom of that fraction. Okay, so now we know how to expand these logarithmic expressions. Let's talk about how to condense them. So now we have two separate logarithms added. We want to write this as one logarithm with the parts multiplied, divided, whatever it happens to be. Well, first of all, let's deal with these numbers in front and write them as powers. So we can say this is the natural log of 8 squared plus the natural log of x to the fifth. Now we have two logarithms added. That same property we are working with tells us that we can write this as one logarithm with the quantities multiplied. And in fact, we should clean that up because we know 8 squared is 64. So there's our final answer. Notice this is the exact same kind of problem that the past two examples covered, except now we're going backwards. So again, we should be able to go from one of these forms to another one of these forms very quickly and easily. There are some cases where the second of these is much easier to use. There are some cases where the first of these is much easier to use. So be able to go back and forth between these. Okay, I have one more example, same exact directions, and then we'll wrap up these notes. Condense the expression to a single logarithm. So first, let's deal with the numbers in front and write them as powers. So that gives us the log of x to the fifth power minus the log of y to the second power plus the log of a to the third power. Now notice, two of these quantities are added, these two. One of these quantities is subtracted. So when we write this as a single logarithm, two of these quantities will be on top of the fraction, one will be on bottom of the fraction. So I can say this is like the logarithm of x to the fifth times a to the third over y to the second. A little bit different from what we had before because one of those quantities is subtracted, two are added, meaning one of those quantities will be on the bottom of our final logarithm, two will be multiplied. Again, knowing how to go back and forth between the expanded form on top and the condensed form on bottom will make some of the work we do later on in this unit much, much easier. So get this practice so that you're really good at going back and forth between these two forms. Okay, that wraps up the notes for this section, so please take care of this assignment on page 211 before moving on to the next set of notes.